Hello friends, welcome to Learner's Planet. Friends, this is our third session for logarithm. In the last session, we have discussed some problems, some very basic problems. In this session, also we are going to take some more problems on logarithm and its properties, right? And I'm sure you are having your paper and pen with you, and this time you are going to solve the problems right with me. Okay? So let's begin. Now this one seems to be complicated. Let's try. See here, 1 upon log 3 to the base 5, right? So if we wish to take this expression in the denominator, then index and base will be interchanged. So this is actually 3 raised to 4 and this is log of 5 to the base 3, right? So precisely this is this. Now this and this is same, so final answer will be this only. So 5 raised to 4 is 625. That is the value of this expression. Similarly, this is 27. I write this is 3 raised to 3 log of, this is 3 square and this is 36, right? So let's simplify the this power first of all. Listen, just watch carefully. How do I solve that? 3 log of, this is 3 raised to 2 and this is 6 raised to 2. So this 2 and this 2, they will come this side. So 2 by 2, they will be cancelled, right? Now, this is what? 3 log 6 to the base 3. So that will be 6 cube, right? Now this is actually in the power. So 3 raised to log of 6 to the base 3. So this 3 and this 3 will be cancelled. Finally, you are left with 6 cube. Okay, just write it on the paper 2-3 times. After that, you'll be clear, right? So this is 625. Then this is 6 cube, that is 216. So obviously we don't have any other option by which we can add and get the answer except 890 because all the other options are less than 625, right? So no need to solve it further. Okay, and if you wish to solve, I just solve that also. So this is 4 by log 9 to the base 7. So that's 4 into log of 7 to the base 9. 9 is 3 square. This is over here. So that's 2. This 2 will go over here. Now 3 to the power this 3. So this 3 and this 3 will be cancelled. So you'll be left with 49 only. Right? So 5 and 6, 11 and 9. Okay? Isn't it very easy? You just be having the knowledge of all the properties of logarithm. That's it. Now this one, a lengthy one. Here 7 will go to this 5 over here and 3 over here, right? And we'll multiply all the logarithms. So log of 16 raised to 7. 16 is 2 raised to 4. So 2 raised to 4 into 7, 28. Write it directly. By this is 5 raised to 7 into 3 raised to 7. Okay? 5 into 3 and the power 7 will go over here. Into this is 5 square. So that square into this 5. So that's 5 raised to 10. By this is 24. So that is 8 into 3. 8 is 2 cube. So 3 into 5. 2 cube. That means power 3 into this 5. It's 15. And 3 raised to 5. Okay, because you need to like skip some of the steps, else you will ending up spending huge time, right? So log here 81, that is 3 raised to 4. So 3 raised to 4 into this 3, it's 12. And 80 is 16 into 5. 16 is 2 raised to 4. So 2 raised to 4 into this 3, 2 raised to 12. And 5 raised to 3, right? Now what? 2 raised to 28, and here we can see 15 and 12, 27. So it's just 2, only 2, right? 5 raised to 7 and 5 raised to 3, that's 5 raised to 10, cancel. 3 raised to 7, 3 raised to 5, 3 raised to 12, that's cancelled. So you are just left with log of 2. So that's this. Okay. So once again, you should be clear about the properties of logarithm and you should be able to apply them in a faster manner, right? Just skip all the 3 steps, okay? Else you'll be ending up spending up a lot of time. Now this one here, log 5 to the base 4 is A, log 6 to the base 5 is B. We have to find out log of 2 to the base 3. Now this one is actually log 5 by log 4, and this one is log of 6 by log of 5, and that's AB, right? So this is this. Okay, so log 6 by log 4, that can be written as log 6 to the base 4, that's AB. Okay, or if I write instead of 4, I write 2 square. So this square will be 1 upon 2 over here, and that 1 upon 2 will go this side, right? So log 6 to the base 2 is 2AB. Now this 6 can be further broken to 3 into 2, right? So log of 2 but we want 3 to be in base. So this is 1 upon log, or first I write log 2 to the base 2 into log of plus log of 3 to the base 2, right? So this is 1 plus this expression. So 1 plus log of 3 to the base 2 is 2AB, right? So this is actually 2AB minus 1, but we want this, so that's 1 upon 2AB minus 1, right? I hope you are getting it. If first time you are not clear, just do write it on paper. So after bit practice, you'll be able to get that. Okay. This one, for the base, here it is k is in base and here k is in index. So I just write log x by log k into log of k by log of 5 is equal to log of 5 by log of x, right? So this is this. So, and this can be written as log x to the base 5, and this is actually log of 5 to the base x, right? Or we can say log x into log x is equal to log 5 into log 5. Log x whole square is log 5 whole square, right? So x can be 5 definitely, and even x can be 1 by 5. Why 1 by 5? See, if I write x as 1 by 5, so it will be x log of 1 minus log of 5 whole square, right? X is 1 by 5, that means log of 1 minus log of 5. So log of 1 is 0 minus log 5 whole square, so that will be also log 5 whole square, right? So x can be 5 or 1 by 5. So we have two options correct. Okay, be careful. Do not blindly mark x as 5 because that will lead to negative marking. Okay. Once again, base here a and here base is a, here index is a, right? So this is actually log of a by log of 5, and this is log of x by log of a. So finally you are left with log of x by log of a. That's 2. So this can be written as log of a raised of x to the base a, and that's 2. So that means, I'm sorry, this is 5 actually. So this is 5. That means 5 square is equal to x. That means x is 25. Okay. Now this problem, friends, we have to solve this equation. See, here it is 0, right? And we know that log 1 with any base is 0, right? And here we are initially we are having log 7. So this can be written as log 1 to the base 7, right? Log, I just write it for you, log 5, this story is equal to log of 7 to the 1 to the base 7, right? So that means this thing, this entire story must be 1, right? If you take first step anti-log. So log 5, this story I suppose it to be p is equal to 1. That means 5 raised to 1 is equal to p, right? So 5 raised to 1 is 5 and that is p. So that is x square plus 5 plus x square root. So if I eliminate square root, I'll be getting this. Now it is x square plus x minus 20 is equal to 0. So that means x is equal to minus 5 or 4, right? Now x is equal to minus 5 or 4. We don't have minus 5 in the options. We have 4 in the option. So that's true. Apart from that, in case of logarithm, you need to be careful also, right? You just try to put up x is equal to minus 5 over here. Let's see what happens. So it is 5 minus 5. That's cancelled, and 5 square is 25. So that will also suit. Okay, because you are getting a logarithm of a positive value over here. Okay, this value should be definitely positive. So in case of minus 5, it is also suitable. But since we are given option as 4 only, we'll be taking 4. Okay, I hope you are clear. And if you wish to avoid the paperwork, what should be your approach? See, this should be 1 preliminarily, as I have told you, because log 1 is 0. Since you are having 0 over here, that means this quantity should be 1 from this, right? That means if this quantity is 0, that means this thing should be 1. In that case, this and this, both of them should be same. That means root of x square plus 5 plus x should be 5 only, right? That means if it is this quantity is in the square root, that means this quantity must be 25. Getting my point? X square plus 5 plus x must be 25. That means what? If you can put up the value of x from option and just see where it is 25. So right away, if you put 4, you'll be getting 16 plus 5, 21 plus 4, 25. Right? So this quantity is 25. After coming from the square root, it is 5. Log 5 to the base 5 is 1 and log 1 to the base 7 is 0. Right? So no paperwork is required at all if you can visualize to a certain extent. Okay, I hope you are getting me with both the methods. You are clear. Okay, now in this question here, this is a geometric progression, or we can say an infinite geometric progression, right? 1 by 10, 1 by 100, 1 by 1000 and so on. So what is the sum of an infinite geometric progression? That is a upon 1 minus r. Here a is the first term, r is the common ratio. How do we find out the common ratio? Second term divided by first term, right? So here first term is 0.1, that's 1 by 10. Common ratio is also 0.1, that is 0.01 by 0.1, so that comes to 0.1, so that's 1 by 10. So 1 minus 1 by 10, that's 9 by 10, right? So sum of this series is 1 by 9, right? Now we got this, and the next thing is 0.05 is what? 5 by 100, or we can say 1 by 20, right? So precisely it is 1 by 20 raised to 20 raised to half, or this is actually 9 raised to minus 1. Now this 20 raised to half can be written as 1 upon 1 by 2 over here. So that's 1 upon 1 by 2, so that's 2, right? Okay, just watch each and every step carefully. Now this minus 1 can be taken over here, so that will be minus 2. So 1 upon 20 raised to minus 2, so that will be actually 20 raised to 2, right? That the story is eliminated. Now this is 20 raised to log of 20 raised to 9 square, right? This square will go over here. So this and this is same, so finally it is 9 square, that is 81. Okay, so various time we are using this property, log of a raised to b, the base, and p raised to q. So it's q by b log of p p to the base a, right? The same property we are using everywhere, right? Here in this calculation, in both the calculations, right? So you should be clear about it. It's going to be an important one. Okay, Now let's see some of the inequalities based on logarithm. Here log 3 x to the base 3 is greater than 3. Then we have to find out whether which of the following option is correct, right? So what I do, here it is 3, so what I can do, I can multiply by 1. Since here base is 3, so I also take the base is 3. Now if I wish to make it 1, what I have to do, log 3 to the base 3, right? Now log 3 x, it is log 3 cube. Okay, now log 3, right? That means what, if we take anti-log, we are left with x is greater than 27. Getting my point? If I take anti-log, because directly we are having log 3 both the side, so we can take anti-log. In that case x will be greater than 27. Okay, so this way you have to go. So basically you should be clear that if we take anti-log, how do we make an inequality or equality. In this case, see, if x is 27, log 3 27, that means log 27 to the base 3 is actually 3, right? So if we want the value more than 3, that means x should be more than 27. That is but obvious, right? But this is the process that you have to follow. Okay, so this is you can say a shortcut that was directly you can answer. When you put x as 27, you'll be getting the value as 3. So the any value more than 27 will produce this to be more than 3. Okay, see the next one. Now in this case, see, once again I'll tell you both the methods. Log 3, log 4x is greater than 0. So we should start, in case of logarithm, just start from the leftmost side, right? Here it is 0. Now I want 0, but base must be 3. So what I'll do, I'll take 1, right? Now if I take anti-log, what I'll be getting, these terms will be eliminated and I'm left with this, right? Now what the next step is, this one can be written as 4 to the base 4. Now if I take anti-log, x is greater than 4, as simple as that, right? Now what, you got the answer. I tell you the other method. See, if what you want it 0 over here, that means this term must be 1, right? So if this term is 1, then it is 0, equal to 0. That means if this term is more than 1, then the right hand side will be more than this side will be more than 0. Just listen to me once again. If this is 1, we will be getting 0, because log 1 to the base 3 is 0. This entire term, if it is 1, right? So if we want this entire term or left hand side more than 0, that means this should be more than 1. That means this should be more than 1. So if it is more than 1, that means x should be more than 4, because log 4 to the base 4 will be 1. So if you want it to be more than 1, then x should be more than 4. That's it, right? So it's very simple, with practice is required. Now here in this case, we won't go for any paperwork. 1 is what? Here the base is 10. So 1 can be written as log 10 to the base 10, right? So if I take anti-log, x must be less than 10. Okay. Now the next thing is, see, for the logarithm to be defined, this quantity, that is index, must be positive quantity, right? So you got x is greater than 10, but since x we want to be positive, it should be greater than 0 as well. Okay, so that's this. I hope you are getting me. Now this question, we have to find out the value of x. It is 2 raised to 1 upon this quantity. So if I take reciprocal of that, base and index will be interchanged. So this is 2 raised to log of x to the base 8, right? Now 8 is what? 2 cube. Okay, so this is 2 raised to log 2 x raised to 1 by 3. Now this and this is same. That means x raised to 1 by 3 we are left with. So y is x raised to 1 by 3. That means x is y cube. Again the property we have used. I hope you are getting it. Now this problem. To be able to solve this problem, you should be having the basic knowledge of trigonometry as well. you must attend the basic sessions of trigonometry. Here log 10, 1 degree to the base 10, log 10 2 degree to the base 10, and the counting is going on till 10 50 degree, right? So friend, while writing, in the middle there must be this term, obviously. So I'm sorry, this 10 45 degree, right? Now 10 45 degree is what? 1. So what we are getting? Log 1 to the base 10. Now log 1 with any base is 0, right? So we are getting a term as 0. That means the entire calculation, the entire multiplication will be 0, right? So this is very simple one. Here in this case, in the basic sessions of trigonometry, I have told you this 10 90 minus theta is cot theta, right? And 10 theta into cot theta is 1, right? Same property we are going to use over here. Now this is log of 10 1. So all the terms are added. So precisely it is 10 1 degree into 10 2 degree till 10 89 degree, right? Now what? 10 89 is what? Cot 1. 1088 is what? Cot 2. So 10 1 cot 1, 10 2 cot 2, right? So the what we will be getting? 1 into 1 into 1, that means 1 1 1 only, that means log 1, that's 0, right? So if you know this property, you can solve this problem very easily, right? So basic knowledge of trigonometry you must have. So for that you must attend the basic trigonometric sessions. Okay. Friends, good number of problems based on logarithm we have discussed in this session. Now I'm sure you might be finding this topic quite interesting and easy as well. So do try some of the problems based on logarithm. So this topic will be really a cakewalk for you. Okay, bye bye.